welcome everybody. Good morning, good afternoon, good evening from Silicon Valley. I am Marek. I am your host for today. And today we are going to talk about Kafka and Kubernetes OpenShift World Tour. So I'm pretty excited because it's a new theme with OpenShift today. I think there is one more thing, that's a green button. Please use it to sign up to IBM Cloud. And this button will allow us to kind of track if you like this event, and if you sign up to IBM Cloud, it will be very helpful for me and for our team to say to our management that these events are really fruitful for you guys. So I'm just adding this link over here if you don't want to click the link, the green button. So just in case you have it in two places, and feel free to ask questions as I said, and respond to our polls if they happen. So the agenda for today, we have an intro to containers, a little bit about containers, and I have about that I will have a couple questions to you first, but let me go through it. So how containers are hosting microservices, and we'll do very quick Docker build ship run demo, hands-on demo, so you can join me if you have Docker installed on your platform. And then we'll do introduction to orchestration, how to manage many containers, just not one. And I will talk about Kubernetes, and I will talk how Kubernetes is a part of the OKD project and how it evolves to OpenShift. I will just touch base about OpenShift versus Kubernetes, and we will do lab 1, which is a lab that introduces you to using OpenShift and or Kubernetes on OpenShift, because Kubernetes is a part of OpenShift, and OpenShift is just a curated flavor of Kubernetes, in my opinion. And then we'll do the Kafka on Kubernetes, so the lab that it's very extensive lab, and there is a lot of instructions, so it will be do-it-yourself kind of lab. I will try to navigate through it quickly, but I don't know if I have enough time to do it. So with that, let me ask you a couple questions. So let me get back to, I will stop sharing for the moment, and I will ask those questions here. So let me just try to get it right here. Okay. So I have questions. So is it your first webinar with IBM Developer? So I'm making it visible. And the second question is about if you are new to containers. So please, I will give you a little time to just try to respond to it, and let me know what are your suggestions, so I will be able to adjust my talk with our presentation. Still working. I'm preparing the next poll question. Okay, so what is the answer? Let me see. So some people are familiar with Docker, so I will be very brief on that. Some people are new, so still I cover something. And we have 3/4 of people who were attending our previous event. So welcome back, so I would say. And hello to the new visitors. It's so nice to have new people joining us. So let me start with the with our next part. So I need to start to share the screen again, and I'm back to sharing the screen. All right. So why containers? So there's a challenge, or we call it a matrix from hell, where you have a lot of various elements that are being deployed. So static websites, user DBs, queues. Like today, we are going to work with the Kafka API endpoints, analytics DBs, background workers, a lot of various components, and in various provided to you in various languages. On the other hand, you deploy it in various environments, so development virtual machines, staging, like QA servers, and then maybe a data center or maybe public cloud. You have some contributors who are coming over. They try to run everything. So that's a pretty difficult environment for everybody. So because of that, we try to kind of manage that, and because of that, we the industry created the container, the kind of the standard way to encapsulate any type of the application, and also to add the common way to for deployment. So these two words are converging together. And if you look at the development, which how we got to the containers, we started with the bare metal, so providing just the hardware. So you put SSH to the hardware and maybe provide some installation and so on. So you could really install everything on top of your bare metal servers, but you had to install everything from scratch. So you had to install your hardware, then your operating system and everything. Virtual machines gave you a little bit of the freedom, abstracting away hardware. So still you have to install your operating system, but it's the hardware is virtualized. Then comes containers that abstract away operating system. So you just think about just the application servers and your application. I wrote a book about functions, which is the serverless approach. I will share the link with you later on, but it's another way to do it. But today we talk about containers, and functions are having some pros and cons, and containers are having pros and cons. So I will try to show you the way how you can use containers in this aspect. So what is the difference between VM and a container? The basic difference is that container is abstracting away operating system. So you don't think about operating system at all. And you just include some binaries and libraries from operating system if they are needed in your application. Eventually, your application becomes very thin. So in fact, you can install a lot of those containers compared with the virtual machine that when you had to really install the operating system, binaries, libraries, and apps. So you release all this stack, you just keep the application running for you with your application server. So you can really deploy much more on the same hardware. So that's benefit. And Docker came as a very popular platform to do it with the build, ship, and run approach. So that's pretty amazing thing to use, and we will try to do it just exactly that. And you can build your application with existing images, so it's super simple to use. And I will give you some examples right away. So you have like Ubuntu, you have MongoDB, you have Nginx, and some various ways to use those. And you can deploy them on your development machine, so your laptop, your desktop, or you can deploy it on the server, and you have various versions. And you can deploy it in the cloud, like IBM Cloud or some other competitors out there. And development and operations meet together because on one hand side, you have all these code dependencies. On the other side, you have all these operational dependencies that are being merged and provided to you via this container technology. So what are the components in the brief? When you install for example, Docker on your machine, you would install the Docker engine, you would install the CLI. So CLI allows you to talk to the environment. You would create images on your machine, but the images are pulled from the registry, and you can have two registries. One registry is the registry that is being made available for you through the Docker, so it's a Docker Hub, or you can use the private registries that are available through various providers like IBM or for example, Red Hat OpenShift is providing you internal registry to store your images just for your company. So also you expose the ports, and this is one of the examples we are going to do, is exposing the port for your application. Another very intriguing and good engineering aspect of our of Docker is that you would use layers like an onion. You would put the first layer, or transparencies. Think about transparency. So you would put the one layer, then the second layer. For example, you would use Ubuntu on a couple of the services, and then you would install Tomcat, Open Liberty, and some other applications. They will stick on the same platform, so you would not load them again. They will be already available for you. So like a transparencies on projector, and then you would install your application on various platforms. So hands-on, very quickly, you have to sign up with the Docker, download your community edition or Docker desktop, which is free of charge, and you can run your first container. So this is the hello world that we are going to run. Let me try to do it. So Docker run. And we are going to run image of Ubuntu. So I downloaded it before, and we are going to run a command, echo hello webinar on Kafka OpenShift. So what it's happening, we are running Docker, and Docker pulls the image Ubuntu, and then executes the command echo, and on the command came over here. So what we have realized, when you run it for the first time, you would see how the image is pulling your entire, the image is being pulled because you don't have Ubuntu. So if you run it on your environment, you would have the such process. Also, for those who are trying Docker for the first time, you have to log in with Docker. With your name that is being provided for you, or you sign up to the Docker Docker Hub. So this is one of the things that you have to use. And what happened really, Ubuntu created a namespace that separated it from entire environment. So it's pretty good. It's pretty good, but it's not quite good because you are running everything as a root. There are ways to avoid that, and they are made obligatory to change from the administrative user to application user when you run your containers in OpenShift. I will talk about that maybe later on. So let's try to do our first translation service with Watson. This translation service with Watson, it's a small microservice that we will run and build with Docker based on this small lab. Let me just drop the link over here for you guys. So it's lab 0. Just drop it here. So I see that Alexander is saying hello from Brazil. Hi, Alexander. Nice to have you here with us. So I'm dropping the lab 0 link. So you just need to click over there. And let me try to use it. If it works, should work, I think. Yeah, it works. It opens our lab. So let me go to the lab 0. So I will move to the different screen. So let me copy it over here. I'll stop sharing for a moment. I'll use this link. Okay, and I will share the screen. I'm sharing the same link as you are using. And share the screen. All right, so we are going to use this link. So let me go to website. So so that's a small lab. So first of all, what you need to do, you need to sign up to IBM Cloud. That's the first link to use. I dropped the link, I think, early on. Let me see if I have it. Yes, so it's the first link I dropped. So you have to either click on the green button over there, and you have to create the language translation service. So when you sign up with IBM Cloud, you will see image like this. I increase the size of it. I can maybe make it a little bit smaller. So you will see that I am using my my book account, which is Serverless Swift over here. So it's a free of charge light account. I am, this is my dashboard. If you want to see services, you can click, for example, here. You can check your services and you will see that the cloud has those services available. I just deleted service that we are going to recreate now. So I will go to catalog. So you can try everything for free of charge and, you know, test it. And one of the ways to do it, you can just type over here translator service, or you can navigate to it through services. And out of 170 or 80 services, you can pick up AI services. So I'm going to pick them up. You have plenty of services. So for example, I'm doing a workshop next Monday on Watson Assistant, which is the chatbot. We have visual recognition. But today we are going to use translator service, which is the Watson translator. We're starting with as the tone analyzer. Translate over here. Sorry about that. So this is the service, and first of all, what we need to pick, the location. So the closest locations for me is Dallas. You might pick the one that is the closest to you. I'm going to use 1 million characters per month, so it's a free of charge service, and I'm going to call it webinar. And I can say Kafka as the tag that I will know that we are using this over here. So I will create the service. It takes just a second. A good time for having a sip of coffee. Okay, service is created. I will just add new credentials that it's easier to delete credentials than the service itself. So I call it Kafka. I'll add this credentials over here. They should appear. And what you need really is to copy those credentials for later. You will need URL and API key for later usage. So you can copy them over. So that's the first step. Very simple. And now if we go to our instructions. So congratulations, we have created the service. That's great. So now we will clone the repository. So I created the directory in my lab environment, and I will copy these two lines. So I will go to the terminal. So so the terminal we were using before. I will clone the directory that was given to me, and I will go into this directory that was just cloned. So I will check it out. Okay, and I have a couple of files over here. So one of the files that we are going to run through is Docker files. So if I go Docker, you will see that we are creating image from these layers I was mentioned to you before. So I'm going to use the image of node. On top of the node, I'm creating some environment variables. Then I'm creating the work directory. I'm copying everything to this work directory. So package JSON. I'm installing everything inside of the image, and then I'm copying the rest of the files and exposing port 88 and running the application. So that's entire file. So if you look more, you have this server.js, which is maybe another file to see how is it being constructed. So very simple file using Express for the microservices server, using also library for language translator from IBM, so IBM Watson, exposing the ports, getting some basic things. So one of the things that we need is URL for accessing the port and API key. And then application, we'll do the translation. So pretty simple application based on the Express and using the library. So let me stop here and let's go back to our instructions. So we will now build the Docker image. You have to use your Docker name. So that's one of the scenarios. So I will just give it my name. I'm trying to speed up because it's we have a lot of to cover. Blue Marek S. That's my Docker name. So it builds the image very quickly. Image is built. So now I am going to. That's the explanation. I'm going to run our image. So we need to run the image with a couple things, as I said. So first of all, I need to put it. Put again my name, Blue Marcus. Then I will insert over here the API key. API key comes from the copied file. I didn't copy it. In fact, I just pretended I will show it to you. So API key is this entire line over here with quotes. So this is what I am going to give it over here. And the second part of it is the URL. So I'm going to copy URL without the quotes because they are sticking already there. So I'm going to just copy from here to here, and I'm going to copy it over here. Okay. Okay. So image is there. It's running, and now we can access the image by using the commands. I'm using curl, but you can just copy over the link and use it in your browser. So just for sake of our lab. So what happens? We are calling the image of running container with the translate command, and we put the text as the parameter, and it responds back with the JSON and saying. It queries the Watson service, so it's super cool service, and you can try it with various translations. So, for example, you can add you can add various languages, translation to various languages. You can see what kind of languages they are covered in our application. So, if I add language. English to German, you would see this. If you add French, you would see French. So command Z. I don't speak German, so I'm not trying to ask this question. But in English and French, I can quickly do it. I think maybe I can recollect Russian. Kakte. So it's quite okay. So these are the translations we got. When it's done, you can wrap up the service. So you have to. There are a couple ways to do it, but maybe that might be the easiest. You can see what kind of services are running. You see this service is running here. So you can say Docker stop container stop and put the name. And then when container is stopped, you can delete the container, so it's not going to consume the resources of your system. Yeah, so it's deleted, and now you can go after the image. So it's one of the things you probably would like to do. You would query all the images and so on. So that's the first lab. So I shared with you the first lab. Let's go back to the. So let me just ask the question at the poll if I need to answer some questions. So we need to go to the lab. So I will stop sharing for a moment. So I will just check out if everybody is following me. So ask Paul. So I will hide the first two questions, and I will go to the Watson translator. So do you guys see the Watson translator? Let me see it on the next screen. So I have created, some people are just watching, is your, have you created the microservices Docker? Yes. Still working on it. And no, just watching. So that's so I am asking also about the microservices. So I have created yay. So I will not stop here, and we can go to the lab number 2. So let's start sharing. So before lab number 2, so now everybody is excited. We created the first service. So now second part is let's go over. So we have this one service that is super cool. We think it's cool. We don't know how others are perceiving it. You have a large application that you translate some text, but you expose this API to others to use them. So suddenly you notice that people are using them. Also, you say, okay, let's deploy a little bit more, and you default maybe in some places to English to Spanish, English to German, French to Russian, some other languages, and it becomes popular service. Suddenly you are overwhelmed because maybe this service becomes a really good application. So congratulations to you. In API economy, that's a success when you have such a problem that people are really using it. So now you try to make it billable service, but it's very hard to kind of maintain it. So for that, people started to use container orchestration. And that's one of the aspects that we want to cover now, which is how people are approaching orchestration. So one of the ways to do it is to use the environment that supports scheduling of services, orchestration, so on. There are a couple of them. Everybody is recently turning heads towards Kubernetes as one of the standards, but there are other available. And there are pros and cons to use them, but Kubernetes became kind of de facto standard here in Silicon Valley, and it's being adopted by many companies as open source project. And as open source projects led by Linux Foundation is super cool because it's a container orchestrator. It manages applications, it doesn't cover the machines, so you have to really provide the orchestrations of the machines on your own. And it's designed for extensibility, so so it gives you opportunity to give some add-ons, and I'm sometimes covering other elements like Istio and so on. So that's another aspect. So how entire infrastructure works. So one of the things that you would like to have here. So just pick the color, maybe not red. Let's go with the blue. So first of all, you would put your container over here. So that's your container, and let's say it's our translation service. You would put it here in a container, and then you would wrap it up in a pod. So the basic deployment environment in Kubernetes is a pod. So when you install the pod, that's not everything. What you have to do really is expose the pod through service. And when you define your YAML file, so the YAML file will that's the file that you would probably use to define your services, and you are going to see it. You would say, I want 3 of those services running. So you would have service here and service here. So all those services are being provided. They are spinned in the YAML file, and because of the YAML file, master node will take care of spinning them, and they are going to be exposed. They are going to be exposed over here, so through the service. So that's one of the aspects that you would do. So container is defined inside the pod. All the infrastructure and IP tables is defined here. This guy is being exposed as a service. So you as a client, in fact, you would be coming to the service and asking the service to provide you with the responses, and one of the services based, for example, on the round robin, would provide you with the answer. If that's not enough for you, you would need to have additional for the service mesh. You would use additional plugin. So you would add over here a plugin called Istio. But that's as I said, that's through the extensibility. You would add Istio, and that I love so much to use it and seeing it being done by my colleagues. So I covered services. So this is the part that exposes the pods. The pod is a basic unit of deployment, and container is that what we have done with the microservice before. So with the Kubernetes, we can schedule how our deployments are running, and we can say during this Black Friday sales, we want to deploy more services. They are self-healing, so what they are doing, you would see the services that are being run. If they get stuck, you can have a health check, and you can reboot them, restart them. So that's what's happening. You have a couple ways of making sure that your deployment is sized correctly. So you can have larger or smaller deployments, and you can really define that in your environment. So you are going to see the servers that I prepared for you, the clusters. They will have medium size. They will have three nodes, so 3 worker nodes on, and they will have, each node would have 4 CPUs, and each platform will have also 16 gigabytes of RAM. So these are the elements that you would have, and that's the cluster definition. So 3 nodes, 4 CPUs, and 60 being so 3 worker nodes, 1, 2, 3, like in this example, and each worker node would have some memory on them. Then you would discover your services, and you would have some load balancing available, but it's very basic. So this load balancing, if you want something else, you would go with Istio that I have a log over here. So that's pretty cool. And you can roll out new versions of the application. If something is not working, it will roll back automatically, but you can also roll back yourself. And you can also share the secrets with the cluster without putting them in the file. So it's pretty good, and it's very basic environment. So on that, what are people doing? So either you are going to collect everything yourself and all the components yourself, or you are going to use something that some other people were working on. And already community distribution of Kubernetes, or OKD, is one of the environments that became very popular. So OKD is open source version. Think about this as a CentOS. So CentOS kind of version of the Kubernetes. So it's like a collection of the various components. They are copied here. And what Red Hat was doing, they provided OpenShift based on this OKD environment, and called that OpenShift. So that's the kind of connection. So OpenShift is based on OKD and provides all the libraries, Istio, Kubernetes, and so on. So these are the elements, and based on that, you can deploy it on any cloud. So multi-cloud or hybrid cloud, whatever you call it, you can deploy it in various clouds. And IBM is super excited about using various environments and treating the cloud as the cloud of the provider, being little bit as an abstract layer for us. So using OpenShift for your company might happen on any cloud you feel okay with. So how we compare it, one of the things that, what is the difference between OpenShift and Kubernetes? So as I said, Kubernetes is a part of OKD, and OpenShift is based on OKD. It's just commercial version. It's a product of it is based on OKD. When you deploy it, OpenShift is much easier to do. You don't need to work with your container definition, with working with the with your registry, and you don't need to kind of build your CI/CD story. Everything is taken care of by project, which is inside of the OpenShift. When you manage it, you can rely on the very nice UI. You don't have such a UI in Kubernetes. You have somewhat equivalent of ELK, so Elasticsearch, Log, DNA, and Kibana. This is more or less the same stack as over here. You would need to have for mesh, microservices mesh, you would use Istio over here. Manually over here, everything is Istio is provided, so everything is taken care of. And finally, with the security project, OpenShift project provides us everything that is needed. When you go with the Kubernetes or like without anything, you have to start with the best practices. Use role-based access control, IAM services, authentication, authorization. You have to all provide yourself best practices. You have to apply them. With OpenShift, the project takes care of it, so the best practices are already there. And when you want to add something, some new cluster, because of the growth, there is some way to do it. It's not that easy. In OpenShift, you use just Ansible, so it's super cool and super simple. So with that, we are ready for the lab number 1. So we are almost ready with our final lab, but this lab number 1 is super cool. So so first of all, what we need to do, we need to go with the environment and get the cluster. So let me share with everybody the cluster definition. So what we need to do, we need to come to this website. So Irshad, hello, nice to have you here. So claim your cluster. So we will do this and use key for the cluster is this one. So I will show you how to do it. Hopefully it will work for me. So so let me just move to my environment here. I will open a new page and I will copy this claim your cluster link. So so let me try to do I have to type it? It's not difficult. So os Kafka dot my bluemix.net. See if it works. Yeah, it works. So this is the claiming infrastructure. I have 10 clusters provided for us today. So I will try to claim one of them with my light account. So serverless Swift at robotics.com. So that's my ID, and OS lab is the link. So let me see if it works. So when the drum rolls, so this is more or less what you would see over here. Let me pause here. Let me see if let me see what's going to happen next. But on this moment, what we are getting the our cluster assigned to us, and you will see cluster when you change when you change the organization. So how to change organization? So when you are back in your cloud environment, so just type in cloud.ibm.com or using the green button over here if you haven't used it before. You can simply click on the serverless Swift. So in my case, but I don't see it, so I have to reload it. Let me see if it's going to work. Yeah, it worked. So now I have serverless Swift, and I can choose IBM account advo work. So if I don't use it, if I go to the OpenShift or Kubernetes, if I want to see my clusters, I won't see anything. I can create the cluster for free. I can create the cluster if I spin the cluster. There is a free cluster that I can access. But what I need to do, Kubernetes, yeah, let's say like this one, classic infrastructure, and you can create one not with the 3 workers. But you must choose location. So standard. You see this is the free one, and you can choose the free one and create. And what you need to do, you need to upgrade your account to the PayGo account, and you can then test it out. Without PayGo account, you cannot spin your node. But this is omitted today, because what we can do, if we come back, you can just switch to advo account, and I have been assigned a cluster through the process. So you can claim the cluster that was provided for us. As I said, there are 3 nodes and 4 CPUs each node, and I have this cluster over here. So pretty nice. Thank you so much. It was Mike Peterson who was doing it for us. So say hello, Mike. Thank you for that. So here you will be able to see the cluster and all the elements of the cluster over here. So you can see a number of worker nodes. So so we have 3 worker nodes, and you can have definition, public IP, and so on. Now, what we want to do, we want to open the web console, and I will show you very simple lab. So let me share with you the lab. So when my console is starting, okay, console is starting. So when the console is starting, what I'm going to do, I'm going to give you this link over here. So you guys can, everybody can kind of test it out. So let me try to share the link for lab number 1. So so this lab is super simple lab. It's based on my I also wrote a short article about that, but let's use it. Let's use this link over here. So so I am going to. So I have some authentication error. Sorry about that, but I will see it in a minute. What's happening there? So what we are going to do, we are, you can follow the lab instructions over here. So what I'm going to do is always, what was this? IBM.biz/202010, and the link is Kafka and lab node 0 but 1. And then you would go through the lab. So first of all, you have to kind of add a new project. So you have to change from the administrator to the developer. And I see the problem over here, and I don't know what the problem is. So let me try to restart it once more. Okay. Okay, I'm administrator. I want to change to the developer. I want to add the container image. And I will use container image from the registry, and my lab is telling me I need to use Niklas head of image. So that's the lab number 1. So what we are doing, we are picking up from the registry, from the open source, from the public registry, we are picking up this lab. This guy is giving me some issues here from external registry. So what the heck is happening here? So the link should be coming back here. Niklas Heldorf. Oh, this says you might not have access to the container image Docker. Niklas. Oh, okay. It worked now. So I don't know what was happening. Maybe something. I need to pick up the deploy configuration, so you will have the and I want to create the root. So that's a very simple setup of the environment. Now this is what I was telling you about. This is how the application is starting. So this is UI, pretty nice UI. It shows you that the image is pending. You can just click over here. You will see that container is creating. So what it does when we were running our image over here, so it's getting our image, it builds it in the environment. So I think when we had it over here, so these are the steps that are happening now. It just builds the image. So, and then deploy it in the environment. So gets the environment and it's running. You see now the environment is running, got all the environment. So if you go to the link over here, it will open the link as soon as the image is kind of ready. So we need to kind of, I think, wait for that a bit. Okay, it's ready now. It takes some time to get the image running. So what more we need? We need to all the steps that are being used. We have to add OpenAPIUI. So this will allow us to access the microservice Open API, and we need to put UI at the end, and UI. So that should open for us the UI of the microservice that was deployed in the cluster. So now what we are going to do, we are going to get we are going to test it, and we can try it out. We have one. So we are going to execute, as previously we were executing microservices with the translator. We are just accessing the database without or more. About this exercise is shown in the over here. So you can just follow up the lab, and you can learn a little bit more about that. But today, as I said, so I'm trying to bring up a couple ideas. So we were going. So that's another link that you can kind of use. Let me try to stop start. We try to copy it over for you. So I have it here. So try source to image example with this link. Maybe you can try it out. We are going to share also the links in the follow-up email, but just in case you would like to have it. And the next part is a Kafka and Kubernetes. So it's entire lab provided for you. and you can go to this article or go directly to the environment. So let me copy the environment link for you, so we can start the lab right away. So lab environment. So it will launch for us an environment, and let me give you a couple ideas. So first of all, what you are going to see, it's based on the lab cognitive class AI. It's a free of charge environment that we are going to use. You would sign up or create an account. I'm using my account connected with IBM. It will create for you environment. So in the first step, you will see the environment. Excuse me. And then when we will do the environment, you will scroll the instructions, and eventually you would need to create a new terminal, and the terminal will be here. I'm just trying to cover this for you, so you will for example download the GitHub instructions, and with that, one of the things that you will notice, one of the last steps in OpenShift, you will need to open OpenShift Console. I'm going to show it to you, hopefully. We have a couple minutes more. And in order to do it, you would have to put the inventory systems as it requested in the directions at the end of this link that would be created from your console. So if you recollect, our console looks like this in this environment that is provided for you, so you can test various applications here on Red Hat and having a medium size of the cluster. But you would use this link in order to open the URL. So pretty simple step to do. Let me get back to our lab. So as soon as you start the lab, so this is the lab I made the copies for you. So let me try to see where I am, if it's still working. Yeah, it's working. So I can go to the lab instructions. So let me know if you were successful with starting the lab. And also I have one more question that I was asked to provide you with, which is a survey. So we have a survey, and I created a shorted link for that. Let me just try to open it up. I think I have it in my line over here. So I'm just going to share it with you before I jump into the lab. So I'll try to share with you the screen again, and sharing the screen. So I'm sharing the screen. This is the survey. The survey is going to ask you a couple of questions. How do you like it? And was it any good? I hope it responds to your request. So this is the kind of the survey page. But I'm going to now go through the lab. So this is the lab. There are more labs around Kafka and about microservices and how to build a quick piece of microservices with Quarkus, and which is super exciting library provided today for developers. But we are going to go with the environment. So that's the link for the environment. When you start, you will see this screen. So log into the cognitive class. Sign up, and you should see step number 1 and getting your environments ready. And I have this environment ready. I already did the first step, so cloning the repository. Now I'm going to the next step. So I'm changing the directory. So I'm going to paste it over here. Okay. Can I make it any better? Probably I can. Let me just increase the size. So now you will see whatever I'm doing here. I'm trying to make it as big as it's possible, so a little bit bigger. Okay, can I see it on my screen over here? Oh, a little bit I can, a little bit not, I don't know. But I'm following the instructions. So as soon as you clone the example, you can also use your own environment. You don't need to stick to this one. It might be more difficult. You have now the environment where you can deploy it. You can create two files. So one file is a producer that generates the application. So I'm going to create the file first. So the file is being created, and this file now I can get the code. So the code mostly, if you look inside, it will show you what is inside the code. So let me just try to start system. No, it's a system. I think it's here. Okay. Okay, that's our file. I'm going to put the file here. So let me just make it smaller here. So I'm going to copy this entire file, contents, and description of the test. So description of the file. I'm sorry for the size of this, but I'm trying to navigate the things. So one is the code, and the other one is that you can see something out of it. So so it's not that easy. So the most important part is that we are going to use this outgoing channel to which we will going to produce the interval of 15 seconds. We are going to produce the load of the system. So we will see what's the load of the system. So that's the first step. And this description of that we are using flowable method for Kafka. So now next step, we are going to create a new file. Again, we are going to create now inventory resource. So we are having two files. One file is producer producing messages. The other file in this the coupled message-oriented asynchronous environment is the inventory. So the guy that is consuming the service that is consuming it. So now we have the second file, and the second file we have also the elements as previously. We will update the status based on the incoming messages from system. So I copied this over here. So that's the second file. I have to paste it. I have to save both files. All right, it's saved. And now I can go to the next step. So now we are going to create some properties. So this is this next step. Paste. And over here, these properties, they are appearing here. We are going to create the connector and description of the configuration of the file. So I'm going to copy it over here. Paste. As you see, I am navigating between files and my terminal here. So pretty simple. So I'm saving properties. Now I'm creating the same on the inventory side. So that's one Kafka environment for or properties for producer, and the other one for the consumer. So we are now wanting this for the second connector copied. All right, I'm saving this, so so everything is saved. And now when the two files are okay, we can start the server. So we are going to create the server for our environment in Open Liberty. All right, it's done. And now we can, the server XML, we can just populate with the information, what are the ports, what is the context root for all our microservices and so on. So these are the definition of the system properties. So what is the configuration, what is the port, and so on. Okay, we are going to save it. And when it's done, we can also create the POM file. So quickly doing the POM file over here. And now the POM file is created. So now we are going to fill it out with the definition of all the dependencies, the project, and so on. So I'm going to do it over here. All right, so you have the plugins definition. So we are using, as you see, Maven, the Kafka, and so on. So everything is defined in our file. So we just save it. And okay, so we are ready now to install everything. So all the application is ready to deploy. So we can click install and let's see. And everything is happening in the remote system. So it's super cool. You don't need to worry that it's going to bug your own system or clog your networks. Everything is happening beyond us. So in the cloud, when it's done, you just run Maven with all the packages. So when it's done, all your classes are going to be built with the Maven, and then you can use Docker to pull image of OpenLiberty. So you are going to use, as before I was running something on the on the Ubuntu. You can use the same command kind of. So everything that we have done in today's workshop, we are kind of repeating, but in the environment that's not on the local machine. So we were doing the same. You would see the same image every time you pull something new. So we pull the image. From my presentation before, you can kind of we did that. So Matan is asking, is the recording of the session available? Yes, the recording will be available right after this this webinar is over at the same address, and we will send also links to you guys, to everybody, so you can kind of so there will be the same address for. So if you get lost, you can kind of follow up. So as soon as you are done with the with pulling the image, you can create, according to our instructions, you can create a snapshot. So we are going to build the image. Let me have water because my throat is getting dry. So we have created the first image of the system. We are going to also create the inventory. We are building another image of inventory. Done. So we have created both of them, and now we are going to start containers. So we are starting on the remote local without using other environments. So it starts just the Docker images. So not in the infrastructure that is fully fully prepared. We are hitting the mark of the 1 hour at the moment. So I hope it's okay if I continue. Please fill out the survey on Exit. It would be very, our colleague Irene would be very appreciative of that. So we started the containers, they're running, and what we can do now, we can curl our our environment. So I was doing curl the same way as before. So you should see after some time, we need to give it its time to start, but you should get the response after like couple seconds that the system is loaded and it's running. And you can see every time I will ask it again, the load will be decreasing. So so you'll see that the application is running in a correct way. So that the CPU load, you see 2.81. All right. So we have done it. And now you can go and curl your particular system. So we have the host name over here. Let me just try to get it. Somebody's bugging me. Okay, that's not important at the moment. All right, and I will use this host name over here. So it's not what I wanted. I wanted to copy this link, copy. And I want to paste it over here. Okay. And now it gives me the information about this particular system. So okay. So now we have done the first part of the exercise. We have done it in the Docker environment. So now we are going to work with the second part, which is I'm just going to stop all the containers. So they are going to stop. After that, the next step is the following. So we have containers. So we are going to deploy the application in OpenShift, and we have OpenShift console over here. Let's see if it's going to launch for us. You see, this is our skills network. So over here we'll have our project. You can go to the developer, and you will see, as a developer, you will see the topology of the system, and this is what we are going to do. So let me start to do it. So we are going to copy. And you will see your name over here. So like John Doe. So so now you can confirm the name of your lab by copying this and assigning it to the copy and paste over here. So we assign this environment, and you can just check it out if it works. So so having this here, yeah, it works. Okay, and so now we can connect to our environment. So Bluemix login, we are logging into our registry. We have everything correct, and we have created an environment. So we are going now to push the images to the repository, to the registry. We are not going to use public registry. We are going to use registry of our environment. So this is what we are going to do. So it's our environment. It means environment in the IBM Cloud. Okay. We are pushing this C layer already exists, so we don't need to kind of repeat it. So it's a very quick process. So some layers will be available there. For example, Open Liberty. So that's the second part, which is the same for consumer. Tagging and pushing. Okay. Now what we are going to do, the next step after doing that is creating the OpenShift YAML file. So OpenShift YAML file is the file that deploys environment. So you would use this YAML file for anything required to work with the system. And OpenShift YAML file, it's a YAML, just a flat file that has the definition, as you remember from my previous description. Let me just go there and then show you. When you look at the environment, it will define first the pods with the container. Container reference to you if we use this guy. If you define it, the registry, so you would reference it over here in the registry, and this registry is provided with the cloud. So there is some cloud, and you have the registry available there. So so that's the point we have. And so getting back here, so we are going to create the first application system, reference the images, and then we have the deployment and the way how it's going to work for us. And you define the services. So services, that's the part, this part. So you define the part that is going to talk to each other. And so you define the services for inventory and for Kafka. And then, so now we are ready to copy this inside our YAML file. So this is what we are doing. I'm saving it up, and now we can, we will look over here. So let me just, we replace the name that we have over here, because we put the name. Let me see where it is. We are replacing our namespace name with my namespace name. So as soon as I do this, you will see my name is being replaced with the SN Labs and Sados. So that's the step for that. And now we will deploy it using this OC command over here. So pretty simple command. Let's apply this OpenShift YAML to the cluster that we are assigned to. And cluster is being created. And now if you come back to the to our environment, no, not this environment, you will see in a moment that everything starts to roll over there. So and what we need more, we need also the root. Paste roots. You will see the roots that are also going to appear there. So you see now an environment is having more elements. We have Kafka that is still starting. So as soon as Kafka is started, we will be able to use the system. It's running. Oh, now it's running. So it's changed the status from the light blue to the blue. So as soon as it's done, you can your root will look something like that. Yeah, it looks something like that. So it's a fully defined root, and now you can use this root to access the system. So so as I said over here, if you recollect from our system, you would need to put the inventory systems over here. So what I'm going to do, I'm going to use this tip and go back to our system over here. So I will use this. I will open this URL. Okay, it's opening, and what we are going to use, we are going to get the inventory systems at the end, so it will show us what is needed. So inventory systems. Okay, and it gave us the response over here. So system load is 1.0, and if you reload it, you will have the system response from time to time. So there is some troubleshooting. You can see all the pods that are being deployed. If you don't believe your eyes in the, so you can see the deployment. So pretty standard deployment of everything, and you can have. And eventually, when you are done, you want to clean up after yourself. So you would delete OpenShift YAML. So this entire environment is going to disappear. I mean, not the entire, but this application. So if we delete it, so deployment and services are being removed. So if you come back here, you will have just a very empty space. And with that, we are done with the lab. So congratulations, well done. You survived through the lab. What's more for us today? Let me just go back to the. So thank you very much for joining me. Join me for my office hours. Use Slack. Usually I'm available every Friday and every Monday from 11 to about 1 p.m. Pacific time. You can connect with me through my Slack. Let me get the Slack here. I recollect I had the Slack somewhere. Join my Slack. So this is the link. Join me on Slack. Join me on Slack. For office hours or ad hoc questions, usually I'm receiving a lot of information. So this is Slack. I just send sometimes announcements. Join me here. So if you guys join me, and so we will be able to have the conversation one-on-one, and maybe you can share some of your challenges, and also feel free to browse for my book. If I open a new environment and I write a serverless Swift, it should open a book in US or Great Britain. So you can really enjoy reading the book. It's super great introduction to serverless Swift, serverless OpenShift, or OpenWhisk for iOS developers. Super nice. You don't need to be Swift available. You can read it very quickly. It's a great book. It took me 1 year to write it down, and with Leonard, who is my friend and colleague. And so let me just share the link to it. So Marek's book, Serverless Swift. Have a look at this. Maybe you want to share with me what you think. Besides that, we have one question. Can we have the video after now? Yes. So Dave, we are going to have the video after this entire webinar is over. You will see it right after that. So thank you very much for the question. So I don't see any more questions except for the recording, and with that, thank you so much for joining me today. That was Marek. I'm signing off. So have a great day, and I hope you will see us again soon. So thank you. Bye-bye.